Hello everybody, Michael here, and let's move on with C programming, and I'm going to talk about the basic building stones like types, operators, and expressions. And well, hang on and let's see what I have here. Oops, there we go. I have a agenda. Uh, Basically talks about how to define our variables, what kind of data types we can expect, how we do with declarations of variables, the concept of type conversions, arithmetic expressions, and some of the operators. This is basically what we can find in the chapter 2 of the book, the C programming language. So let's start. About the variables name. So we can create variable name, and we can use small to capital letters, A to Z. We can use numbers, and we can use the underline as an identifier. We always start with a letter and or the underscore. And the variable name will differ if we use upper or lower case. So capital A is not the same as the small a. Libraries, when we do them ourselves or when we use them, they often use the underscore as a start for their variable names. So that could be a good concept of using use underscores when you create libraries for someone else to use. Of course, we should not use the reserved keywords. It would not work. Most likely give us a compilation error. Should also, suggestions are to use short names for local variables, and even shorter name for loop indices, like for I equals 0, I less than 10, I plus plus, like that. And when we have external variables that might be global over our whole sort of application, then we try to use longer names so they don't sort of so there is not the match other variable names. Longer variable name, very explicit. What it contains will sort of help us organize the variables. So here's the list of the reserved words, just to memorize them again. So we got auto, break, case, char, const, continue, default, do, double, and so on, volatile, while. Read through them so you sort of have them in your mind and you sort of avoid use them. So save yourself one compilation execution. And having a bit of knowledge of all the sort of reserved words in the language that we are working with. We don't have too many data types, but we have char, int, float, and double. And the char is a single byte, so it holds one character. And if it was sort of the integer value of it could then be 0 up to 255, but that would depend on unsigned or signed. Well, let's stay tuned and get back to that shortly. So it's a single byte. The integer is an integer value of the natural size of the host machine. And then we have float and double, that is single or double precision floating point. So when we come to this sort of a new programming language, I find it's really helpful to investigate how it works. So here I made a small example program just checking out how large could a char be? How large could it be? So I find all these limits in the limits.h include file. So I extract them and made a small programming. And what we see here is that, well, the char has 8 bits. We see a signed char at top. Starts with -1 to 88, and a signed char max goes up to 127. Okay, and then we have a char, and it has the same limits. And then at the bottom there we see we have an unsigned char that can go up to 255, and that starts on 0 then. So we see here it's an 8-bit character data type. We do the same thing with the integer. So here we also have, here we again have a signed or an unsigned integer. So it depends on, do I need to deal with only positive numbers, or do I also need to deal with minus sign integers? So we're having signed and unsigned, and that can be combined with a different integer values then, that is short, int, long, long, long. And these 4 different, they decide what size of integer I can have. So in my program here, we can take it from top to bottom. I start with the short min max value, and then I take an unsigned short max value, and that seems to be a 16 bits number that I can store there. Then I take the ordinary int minimum, maximum, and then I take an unsigned integer, and I see that that is a 32 bits number there. And then we continue with the long, min, max. Then we have an unsigned long, which is 64 bits, and then we have a long, long. And the final one is an unsigned long, long, and that's also 64 bits. So there we get a feeling for what type of numbers can we store in these different type of integers. And then we should sort of select the proper integer type depending on what type of value we want to store in it. And one way why this is important to select the correct data type is, for example, when we sort of incrementing a variable of a certain data type, one value more, and when we comes to the level where it cannot hold a larger value, it will sort of overflow and sort of turn back and counting on the sort of the lowest possible number. So here is an example showing how a short signed integer on my system is working. So I'm giving it a value of 32,767, and that is the max value a short signed integer could have on my system, and then I'm incrementing it. So I'm basically expecting it should end with 68 instead of 67. But no, so it's an overflow, it turns around and it starts on a minus sign instead. So overflow might be good, it might, most usually I guess it's not good. So we need to be aware of this is what happened, and one reason why we must take care when we select the data types we are working with. This is the same example program, but now I'm dealing with float and double, and these values I'm finding in the float.h include file, and I'm just printing out the minimum and maximum value of a float variable, a double variable, and then we can also create a long double, and that is a lot of sort of precision figures we can have with that. Okay. A bit about constants. So constants we have when we have read-only values. We could have it for being more explicit, verbose on what's happening in our code. So I'm having 3 examples here. And we can start looking at the row 4, where I'm defining max something to have a value. So this is some kind of macro, I could basically call it. Well, it's a define. Max something, I can use that anywhere in my code. And when the C processor takes this and compiles it down at the first step, it will replace max something with its value in all its places. So that's what the define does. It's used in the first compilation step of the preprocessor. So there we can basically write anything, like we don't have to write 1337. We could write an if statement or whatever we want to. We can write small macro there. So that is how define works. Then on the lines 6 and 7, we see a constant value. So here I'm defining two variables that are supposed to be constant, read-only, not to be changed, and I'm also initiating them with a constant expression. On line 9 and 10, we see two examples of the enum variable, so the enumerated variable type. So what I do there on line 9, I'm defining a type called enum vote, and then I'm providing it with two values, no or yes, so supposed to some kind of voting system. And on the other line, I'm creating an enumeration variable month for sort of enumerating all the months in the year, so January, February, March, April, and so on. And these values, behind these strings, so I can use the strings here when I'm writing my code, but the sort of the preprocessor actually sort of will replace these strings with a value, and behind the values, if we look at the vote there, so no, it's a 0, yes is a 1. So when I'm having this enumeration type, it always starts with a 0, and then the other gets appropriate value incremented by 1. And that's why I'm doing this with a month, just to be a bit more, well, January month is the month 1 in the year. So there I'm explicitly stating that January should be 1, and then the enum type is just incrementing February to be 2, March to be 3. So that's how they work. So these types of constants could be very, very useful in sort of giving, well, some verbosity to what actually happens in your code. So those can be helpful in getting a more flexible code. Boolean variables does not exist in C89 that we are focusing on here. So this is an example where I want to work with Boolean variables. So I'm doing a type def. So type def is defining a new type by using an older type. So here I'm having an enumeration of false and true, and I'm type defing it to a new type that does not exist, but I'm defining it and calling it bool. So on line 8 and 9 there I see I'm using the newly defined type and sort of working with its true and false value. So this is a good way sort of to also create verbosity to the language, to the source code, to show a bit more on what is actually sort of happening. However, in C99, the version of C there is a std bool in a header file that is actually doing exactly what I'm saying here. So we having defined a type of Boolean. So in this sense, we can work with Boolean directly with support from a standard header file. So that is a good thing. We always need to sort of check up and take care of what versions are we actually sort of working with, to know what sort of features of C language is available. About declarations, we should always declare the variables before we use them. So always declare before usage, or we get a compilation error. We can initialize them once with a constant expression that relates to the static and external variable classes. Let's take a note on them shortly. Variables that is declared auto, perhaps within functions and blocks, they are initialized upon each entry. So auto is the default storage class, so you can leave it out. So the variables within sort of a loop or a function within those blocks, they are always defined the next time we go into the loop or the function. External and static variable classes, they are initialized to 0. If we have an auto variable, well, if we just have a variable then, without an initializer, then that will get a sort of a value of, well, we don't know, so we call it a garbage value. So it's really dangerous to read a variable that has not been initialized when we're in a function or in a loop block of code. So really assure that when you're reading a value from the variable, ensure that it actually has been some kind of initialized. And yes, apply const to the value if it's not going to be changed, and that is read only. Just apply const. Good manner. About these variable storage classes we have, so auto is the default storage class, so we don't need to apply that to the variables declarations. You write this variable storage class in front of the variables, so we don't need to do that. Doing extern, that is a global variable, so it can be reached from wherever, so it's an external defined variable, global variables. Static variables can be declared inside a function, for example, and the feature of a static variable is that it contains its value between calls to the function. So you can have a static variable and declare it to be sort of 1. And then you increment it, so you have a value of 2. And then you leave that function. And next time it comes into the function, this static variable will not be initialized again, so it will retain its value of 2. So it's sort of a memory between calls to this function. So it's quite useful sometimes. There is also a register storage class, and that sort of proposes that the variable should go into a register. But you can't really depend on it. It's sort of dependent on the compiler and the architecture if that actually happens. But you can sort of suggest it if this is a variable that you're using very much a lot. Oops. So something about the operators, just a quick view on it. Here are the ordinary arithmetic operators: plus, minus, multiplication, division, modular operator. So here is just an example where I'm calculating a leap year using the modular operator on 1 year, on one line, together with some Boolean operators and logical operators and equality comparison operators. So basically what you are sort of used to when you're doing math, of course you can have the same operators here. The relational and logical operator, so the relational is then greater than, greater when equal to, less than, and less when equal to. So it's for comparing values. The logical there is and, or. So there you can have this value and this value will sort of evaluate to sort of the result from the expression. And then we have the equality operators there, so it's comparison or not equal to. When we run our program, there might be what is called implicit type conversions, and that is converting a value from one type to another type. And this might happen, and it does happen, and it's a bit up to the sort of compiler how it's actually done and when it's done. So it follows some kind of system, so it's okay to converting a narrow operand into a wider one because you do not miss any sort of information from it. But you cannot sort of, there are many of these implicit conversions that provide a valid expression. So even if there are different types, there might be implicit type conversion. You might not get a warning when you compile because they are valid. So you can even use characters, since they are small integers, and they can be used as such in an integer sort of calculation. So you should be aware of that this happen, and you can protect yourself by doing explicit conversions. Let's see on that soon. The header type H type header file contains different utilities that you can use to check and convert between values. You can check if it's a digit, you can sort of modify it so it's to lower or higher, so you can check the content of a value and then sort of adapt appropriately. An explicit type conversion is when I'm, as a programmer, writing that expression should be casted to this type. So we usually write that as in the middle here. So we're having a parenthesis, and then I say type. So integer or char or float. And then I have the expression, and the result from that expression will then be explicitly casted to the specific type I have written. Here we have an example where I have an integer variable, and I'm explicitly casting the result from this function that is obviously returning a double value, and I'm casting that to an int so it can safely be stored in my integer. So I would suggest that you usually try to use explicitly cast for visibility. It's more obvious what you are trying to do, and you seem to be on top of things. You have control when you're doing this. But of course, maybe you do implicit conversions and you're happy with that. If you have control of it, you should just be aware of that. These conversions of data might sometimes be a sort of a source for troubles, error in your program. So take care. Implicit or explicit, there are your tools. We have increment and decrement operators in the language, and we see here that the increment and decrement, we can put them after or before. So if you have another programming language, I guess you're most usually used to this. But let's take them and see what is actually the difference between them. So the first two there, where is A and then the operator. So that actually works like, first take the value of A, then increment decrement it. First take the value of A, then increment it. So that result up there, sort of, since it is an expression, it will leave a result. So that result, if A equals 1 up there, so at the first one, that A++ will leave the result of 1. But the variable A will contain the value of 2 after it's executed. Let's compare those to the second one here, where we have, this is the, taking the same example here, is here we increment or decrement the variable and then read its value. So if A equals 1 to start with here, and then we do plus A, then A equals 2, and the result of that expression will be 2. So it's first increment the variable, then read its value and leave it. Okay, so that is the difference in which order we use these increment and decrement operators. This is C, so maybe we want to do bitwise or work with bits. And then we have a set of operators to work with. So we have the AND, we have the different OR operators, we can shift left or right, and we have the UNOR operator. So we'll be fine even working with bitwise operators here. And just for the fun of it, can you create a program like this? Sometimes I find it quite helpful to just print out the actual bits, comparing a sort of an integer value, write it out as bits. Maybe it's good when you sort of not used to working with bits value, you want to see what okay, so the integer value seems to be 32, but what type of bits do I actually have put in there? So this is just for visibility, just for fun. Can you do it? Try, could be useful for you. This is an example of the assignment operators and expressions. So on top there we have just variable a equals a plus 1. So the expression a plus 1 will be sort of assigned to the variable a. And if we want to do this a bit sort of quicker manner, when we're sort of incrementing or decrementing or changing the value of the same variable, we can do it with plus assignment, minus assignment, multiply assignment, divide assignment, to make the expression a bit more dense. We also have the conditional expression. This is also called in some languages the short ternary operator. So this short ternary operator is a combination of the question mark and the colon. And it basically works the same thing as an if-else statement, but it is an expression. So if we look at this example here, we see an if-else, and this is a particular if-else statement that can be rewritten to a conditional expression where set is equal to if A is greater than B, then the question mark, you read that as then leave A, else colon leave B. So it's a expression if true, else leave this. Okay, short ternary operator, conditional expression. First the expression, and if it's true, then you should leave the value right after the question mark. If the expression is false, then you leave the value after the colon mark. Okay, quite useful and could create a bit more dense code compared to try to write this in if-else statements. Just a quick note about precedence and order of evaluation. So the C programming language follows sort of the same precedence and also associativity of the operators as the other programming language that is equal. And this is also sort of the main mathematical rules we have. You should basically use parentheses to clarify and when you are uncertain. So it's really good practice to use parentheses to visualize how you expect your mathematical expression sort of to be evaluated, or the complete expression. Both for yourself, for the other reading the code, and sometimes also for the compiler when there might be sort of a situation dependent what will actually happen. So use parentheses when uncertain. Good for clarity. And well, that was all. It was a bit about variable naming, working with the different types, the sizes of it, different type of operators. Well, basically the small building stones of a C program. So I do hope that you find it somehow amusing, maybe. And let's move on to start writing some example programs, because that is what we actually need to sort of learn and practice this. So thank you from me for now, and I'm gonna see you pretty soon in another session. Okay, bye for now. Bye bye.